So these are the simple ones.
We do number 2.
Number 2. Very good. Let's look at 2. And I'm on page 8. Let's copy number 2. Okay, y prime equals 10x squared, and we are given that y of 0 is 2. Okay, perfect. So all I have to do is integrate both sides. And when I integrate the function, the derivative, I have to get y by definition. Then here I have 10x to the third over 3 plus a constant c. And now I'm given the condition in order to find c. So when x is 0, y is 2. So 2, this is 0, c. So c is 2. So this is what we've been doing in chapter 4. So then y equals 10 thirds x to the third plus 2.
So this is actually the same as...
It's exactly the same with chapter 4. No changes whatsoever. But very good question. So there were just the simple ones. Okay, so let's go back. Let's share again and tell me what you would like to. Would you like to go look at anything?
I have a quick question about the C.
Yes. Yes.
Why did you put the 2 there?
Because we were given the fact that y at 0 is 2. So when I replace x by 0, y is 2.
The c has to be the 2. Okay.
Yes, and that's how we get c to be 2. Because they were given us an initial condition. So we had to use that. Very good. Other questions?
So the answer would be that equation?
Yes. This is the function. This is the function that satisfies the differential equation y prime equals 10x squared. And it's the only one because we were given an initial condition.
And that was when y of 0 equals 2.
Correct.
Okay.
That was the initial condition. And for the initial condition, we determined a specific function. So there is no family of functions. This is the family of functions with the same derivative. But only one of them satisfies this condition. Which one? This one. No other satisfies the given condition. Okay, so let's look at, again, these are exactly the same. If you want to pick one from here, we can. Let's pick one from there. Or not, because it's exactly the same thing with what we just did a second ago. 23, very good. Let's look at 23. So we have f prime of x equals x to 2/3 minus x, and we are given that f of 1 is -6. Perfect. Okay, so I'm going to integrate, of course, dx. So then the function, when I integrate the derivative, I get the function, is x to 2/3 plus 1, so 5/3 over 5/3 minus x squared over 2 plus a constant c. We are told that when x is 1, the function equals -6. -6 equals, I flip, 3/5 minus 1/2 plus c. Because when x is 1, the function value is -6. So then c will be -6 minus 3/5 and plus 1/2. And the least common denominator is 10. So this one needs a 10, -60. This one needs a 2, -6. This one needs a 5, plus 5. So -61 over 10. All I have to do is go back and plug it in. And I have to. So the final function is f of x is 3/5 x to 5/3 minus x squared over 2 minus 61 over 10. And this is the only solution that satisfies this condition. There is no other. Okay. So I know I have only 5 minutes left, I know. Okay, I would like us to look at one more. Maybe two if we can, if not, we'll stop. Okay, so I'd like us to choose something from here. Your choice. 31, okay, so let's look at 31. Where are you, 31? Yes, dy over dx equals 5x to the 4th y. Perfect. So this is a perfect example for separable. I see y here, and I see y here. I see x here, and I see x here. I have to separate them. I can't integrate. So first of all, let's take it step by step and multiply both sides by dx. Okay, so dy equals 5x to the 4th y dx. This I like, this I like, this I don't. Why I don't like it? It's because it belongs here, on this side, not on this side. So no, obviously I'm going to divide both sides by y. So I have dy over y equals 5x to the 4th dx. Now this is very clear. I will integrate this side with respect to y. I will integrate this side with respect to x. I will use only one constant. Okay. Like before, a few minutes ago, this is natural log of the absolute value of y. Here I have 5x to the 5th over 5 plus a constant c. I will simplify. Like before, the base is e. So the absolute value of y equals e to this. E to x to the 5th plus a constant c. Like before, I'm going to separate these two. E to x to the 5th times e to the constant, which is another constant. I'm going to call it bigger c. If you want to call this c1 and this c2 so you don't confuse them, that's fine too. So then y equals plus or minus c2 e to x to the 5th. Done. This is the solution of this. If we differentiate the left-hand side with respect to x, and we put the function in here, we will get the same on both sides.
Can you go over the
Yes.
last bit again real quick?
Yes, yes. So,
Where you have the absolute value.
yeah, let
of
me
y.
explain all steps. So we understand that this is the natural log of the absolute value of y. And here I have 5 x to the 5th over 5 plus a constant c, and these two go away. E raised to this is the absolute value of y. And I have two pieces. I didn't want to put c1. I mean, we can. If I put c1 there, I have to put it here. So e to x to the 5th plus c1. E to this power equals this. Let me refresh your memory on that. Log base b of x is y is equivalent to b raised to y equals x. This is what I'm using here. B raised to y equals this. So then we can separate this to as x e to x to the 5th times e to c1. And I'm going to call this c2.
That's the part that I was confused on.
Oh, sorry about that. So we had the same step. Thank you for saying that. So e to x to the 5th times e to c1. E to c1, e is a constant, c1 is a constant. I'm going to call it c2. So then the absolute value changes into plus or minus. The absolute value guarantees the plus or minus. c2 e to x to the 5th. So solve by separating the variables. So we did. So we determined the solution. So it's any constant you want. It doesn't matter. Whatever. With plus or minus e to x to the fifth.